checking out my video here. I'm building a ribbon burner forge, and obviously I've already started some of this work. I'm not a content creator, guys. I did something wrong with the original intro to this video, so I don't know, I lost it somewhere. So I'm re-recording part of this video, but this video was never intended to be like a full build walkthrough of how to build a forge and everything. This is mostly just to highlight part of my thought process and show some things that I kind of did different than some of the other people. I do have some of the plumbing done, a lot of the brickwork done. I've also already done part of the frame that will go around it, and the burner itself is complete. So a lot of what I have left is assembly at this point. But some of the things that I wanted to talk about were problems that I encountered along the way. And I kind of debated whether or not I was actually going to make a video at all. However, because of the different issues that I encountered, even watching a lot of the other videos, I just wasn't finding some of the answers to minor questions. Let's talk about the brick here first, for example. Nobody really talks about what bricks they are actually buying. There are different bricks, and you've got your hard bricks, your soft bricks. Specifically, I went with 2.5 inch by 9 inch soft brick that's rated for 2,700 degrees, I think, possibly 2,800 degrees. Everything that I purchased online, I'll post links for in the comments. I had some of this left over from my old forge. Now this is Miko's Red Devil. On Amazon, it was labeled, I believe, as Red Devil 610. They do have multiple products. They all have the same label on it. They almost look identical. But what you want to pay attention to is this one says 3,000 degrees Fahrenheit is the rating. I have used this before to line the inside of my forge, my old forge that had K-wool. It's absolutely trash for that. Do not use this to line the inside of a forge. It will bubble up, crack, it'll create huge holes. It's just a terrible product for lining the inside of a forge. However, I had some left over, and after taking a look at it, I realized that's my fault. I didn't read instructions. I didn't, read the simple information that's on here. This is not designed at all to be a forge lining. It is a mortar designed to be between bricks. Specifically, they say not to make it more than an 1/8 inch thick. But it's nice because it doesn't have a cure time on it. And in reality, using it sets up pretty good in just a few hours. So I went ahead and decided to give it a try with the old bucket so that I could see, how well it would actually hold between bricks. And it held up pretty good. I was actually pretty surprised. So I decided to go ahead and buy more so that I had enough to put all the bricks together. This is I don't know, it's probably an off-brand. It's not made by Lynn. I found these were 12 bricks for like $75, and I got 3 boxes of them. Right now, after having put all this together, I have 4 bricks left over that I intend to use for the doors, the front and back. From there, let's go ahead and get into it and see what we got coming up next. welder, I'm not a fabricator, so I ran into a lot of issues with that. These hinges, I thought were gonna be great. You know, they're nice, heavy duty hinges. The back door here, they actually work out just fine, but this front door here, where all of the heat comes out of when opening the doors, I discovered that these hinges actually have a plastic bushing in here. And that plastic melts, and as you can see, the doors sag. So today we're actually going to be taking the doors off and removing the hinges, and then we're going to install a new door similar to the one in the back, except it'll have some rollers, just like Dennis's video where he uses the pulley blocks up there and it slides back and forth. I'm going to go ahead and use that design as well. There are a few things with the design of this that I was not expecting. Mainly that, so I'm using an 1.25" pipe here leading into my burner. My burner is a 12" by 2" burner, and it's got 18 5/16" holes. I basically used McDonald's straws for the tubes. And initially the burner, I had placed too many holes in the burner, so there was I wasn't getting enough airflow through there, not enough pressure, and I had to plug up some of those holes. But one of the things that I didn't realize was that these supports here, this is just some scrap steel that I shoved in there. Same with here. What I was finding is that because of the weight here, it actually pulls down on this, and then when I placed this scrap steel in here so that it would kind of hold that weight, it created a pivot point there where the fan is actually moving in towards the forge, and this whole thing here tilts, so I shoved this in there as well. In the making of this, this is the second fan that I've put on here. I did have a much lower rated fan, a smaller fan, and I had found that I was having trouble with both gas flow and airflow, and it seemed like I was either I just wasn't getting enough pressure, or I wasn't getting enough airflow in general. I did move to this larger fan, and it seems like it has fixed that in connection with plugging up some of the holes that were in the burner as well. But the other important piece to talk about is that in a lot of these videos, when you're watching ribbon burner forge builds, there's always talk of the PSI that's being pushed through the gas line. A lot of guys will tell you that they're running 3 PSI and they're able to forge weld. Well, that's good. There's nothing wrong with that, except for they're leaving out a piece of the equation, and that is the gas orifice size. Very few of them actually mention the gas orifice size that they're using, and so I initially tried a MIG tip, and the hole is so small that it creates a scenario where you have to use a significant amount of pressure in order to push enough gas through and create enough gas flow rate. So a MIG tip is actually too small. I ended up having to run like 20-30 PSI on my gauge that's here beyond my needle valve, and so upon recommendation, I actually switched to a larger gas orifice, which is a 1/8" size. These are just gas plugs, or these are just terminal plugs there. They were solid. I drilled them out. This one I drilled out for an 1/8" and put that in there, and that allowed plenty of gas. It was definitely running okay, plenty of air, plenty of gas. It was doing good, except for this gauge was useless. I was no longer creating any pressure in here. My pressure at the tank, I was pushing up around 20 PSI. So it's 20 PSI, and then all the gas was just being dumped in there because there was no block here to build pressure. I wanted to be able to utilize this gauge so I could use my needle valve to kind of adjust and monitor and repeat PSI between forging sessions. The 5/64" tip did better. It was still not creating much pressure here. It was allowing the needle to just lift off of the pin, And at max volume here, you know, running 10 to 15 psi at the tank, and this needle valve all the way open, it was only pushing out about 0.5 to 1 psi, which meant that I was still getting excess flow through there without it reading out of my gauge. Eventually, I switched to a 1/16 gas orifice size. Heating up, I will run that at about 4 or maybe 5 psi, and then once it's up to temperature and everything is running good, I adjust it down to, you know, between 1 and 3 psi depending on what I'm doing. I can tell you that it gets very, very hot. So hot that when I open up these doors that it's hard for me to, you know, even with my long handle tongs to get close enough to take steel out of there. Gas orifice size and your PSI are directly related to each other. You cannot compare your PSI to the PSI that somebody else's forge is running, even in a similar setup, unless you know that gas orifice size. The other thing is that the initial burn on the forge here, it can take quite a long time for the forge to heat up to temperature. And I believe that the reason for that is that when I built this forge, I wanted the height here. Some of my items that I work on are tall, and I wanted to be able to put the whole thing in there. I also added 1.5 inch risers in here so that this was about 1.5 inches taller. What that does is increase the cubic volume in there that needs to heat up, and it also creates up in the corners some cold spots where, you know, the heat just doesn't really get to. I'm gonna cut some more of this fire brick and secure it in there with the more of the mortar, and just to kind of fill that in a little bit. It's going to be cut at a, you know, probably about a 45-degree angle there, so I still have the height and I still have most of my width here, but it's filling in the top corners that are useless to me anyways. I don't use that space, so there's no real reason to heat it up. I'll probably also create an additional plug in the back that attaches to the door here, so that when the door is closed in the back, I have a plug back there that kind of shortens the interior of the volume as well. I don't always use that length, so having that plug that I can take in and out of there when I don't need that extra 2.5 inches of space. I bought a PID controller with a thermocouple. We're gonna get that wired up, and we're gonna secure that in through the side so that I can get some accurate temperature readings inside the forge, and kind of try to automate that with a gas solenoid. So with that, let's go ahead and start building out the new door, and then we'll get these old doors cut off and just kind of keep moving from there. All right. right, guys. So I did a little bit of work here off camera, getting the electronics all put into this project box here. Wanted to go through a quick description of kind of how this works, and exactly what the intent here is. For starters, this is the PID controller here. You can see it's got a simple interface there. I will be, keeping the instructions close at hand because there are some options in there that are useful. So if you order one of these, make sure you get comfortable with those the instructions on how to work your controller. But essentially, what we have here is a basic plug here in the back. It does have a on-off switch on it. That will supply the power from a wall outlet to the controller here, the PID controller. From there, the connections, there is a 12 volt output connecting to this side of the SRR. This SRR acts as it's a relay. So as the temperature rises and falls and it reaches its trigger temperatures, it will send a signal to either, it'll send a 12 volt signal there to close the relay switch here. So with the 12 volt signal flowing through here, it'll connect the switch and then allow power to run out through to the gas solenoid. This gas solenoid is normally closed. So with no power, no 12 volt signal, and no, the relay's not closed, then there will be no power here and this thing will be closed, meaning that there will be no gas flow. So in a normal condition, when your forge is not up to temperature yet, this will complete the circuit running to the solenoid, leaving the gas open, and your forge will be blowing. As it reaches that max temperature or whatever you set it at, say it's 1900 degrees, when it reaches that, it'll shut off the gas solenoid, meaning there's no power going to it, and it'll shut the gas off. As the temperature then falls back down below your target temperature, it'll reopen, and the extreme temperatures inside the forge will reignite the gas. It's set up intended this way also as a safety mechanism for the forge. So if for some reason, I've got a daughter, so if I happen to walk out of the shop and I'm checking on her in the yard or something, and I get to pushing her on the swing for a few minutes while my forge is heating up, if for some reason like the power goes out, well, without this, normally you would just have gas continuously flowing even though the power to your fan is off. So you would end up losing flame because there's no fan, and you would just be dumping gas into the forge and into the shop area, wherever it is you're working. But if the power goes out, the power to the fan will shut the fan off, as well as there will be no power getting to this, so it'll automatically shut the gas off as well. So there's a little bit of added safety there. Something to be careful of is that there are multiple different models of PID controller, multiple different models of SRR, and multiple different models of the gas solenoid here. This particular solenoid is a 110 volt solenoid, meaning it requires your standard US wall outlet for power. There are some that are 12 volt, maybe some other varying voltages, but if you get a 110 volt, make sure your
PID controller and SRR are also set up to be able to produce voltage for this. So this SRR here has an output of between 24 and 380 volts. There's no setting on it. It does it automatic. You know, same thing with the input here. It'll accept anywhere from 3 to 32 volts. So you just need to make sure that your PID controller outputs somewhere between 3 and 32, and that your SRR controller outputs the proper voltage for your solenoid rating.
So controller's mounted, thermocouple is in. All I do is just drill a hole through the side and then slide the thermocouple in there. Gas solenoid is on there. Again, I'm gonna get an extension here to bring that out a little further, but you know, I can just move it out of the way here if I need to. It shouldn't be a problem, but so let's go ahead and flip the switch on the back, see what happens. Hopefully it doesn't shock me. All right, it's good sound. I don't know if you heard that or not, but the gas solenoid clicked. When it all booted up, it's reading at 53.6 degrees right now inside the forge there. Looks like it's set at 138 degrees. So if it was running as that reaches the 138.9 degrees, then the solenoid should shut off. There is an auto function and everything to tune it. I'll have to play with it and find out how well all that works. All right, so there's the inside of the forge. As you can see, place some filler brick there. That's where I wanted to just kind of fill in the airspace that I'm having to spend gas to heat, but I don't really utilize that space. So also all the way in the back there, I don't know if you can quite see far back there, but I put another block back there just against the back door. Kind of shortens the inside of that, but I wanted to fill that space as well. I don't need that whole length of the forge all the time. I don't know, I'll see how well that works out. You can also see there on the right side where there's a little cutout in those new filler blocks. That cutout is where the thermocouple is. It sticks out about 1.5 inches, maybe 2 inches, but doesn't look like you can quite see it in the camera. But that's okay. So I'm gonna back the camera up here just a little bit, and then we'll fire up the forge and see how it runs. Put a handle in there, that's for sure. So all right, I'm just gonna let it sit here and run and see how long it takes to get up to temperature. But other than that, my video, guys. I'll try to have some projects up maybe in the future, and maybe that way you guys can see what else I'm working on. I do know I have a treadmill that I got to tear apart. I think I'll probably make a belt grinder out of it. And then I got my Etsy store that I sell some stuff on, so I'll probably have some videos for making a few of those items. But other than that, if you guys have any questions or anything like that, just, you know, drop them in the comments and let me know. I will respond there. You know, again, thank you. Hey guys, so some quick final thoughts here. I spent most of the day editing down this video. There was a lot of footage, and when I went through it, there was about a 4-hour long video, so I had to trim it down a lot. In the process of that, I realized when I got all done that I had edited out probably the most important part. And that was that Dennis Tyrell of Tyrell Knife Works, I utilized his build video that he has up from about a year and a half ago or so, as well as a recent video that he put together rebuilding his ribbon burner. If it had not been for his help and his advice, I did speak to him a few times, quite a few times actually, throughout this whole process to help work through a lot of the problems that I ran across. And yeah, without his expertise, I could not have got through this build as easily as I did. So thank you, Dennis. I appreciate all your help, and you know, your content is fantastic. Everybody else, you know, make sure if you're not sure who he is or you haven't seen his channel, then I'll link it below, and go check out his videos. He's got some great content out there. Thanks again, Dennis, and thank all of you. I appreciate you watching my video. Hopefully there's more to come soon. Appreciate your time. Thanks, guys. Alexa, quit playing music.
Hey, homecoming queen, why do you
Alexa. Alexa.
Sorry, I'm having trouble understanding right now. Please try a little later.
alright?
Alexa.
So good at smiling.
Alexa.
Sorry,